Hey guys, welcome back to AlgoYogi. We are doing two pointers up series, not approach, two pointers approach series. And our next problem in the list is valid palindrome second. Let's go to the problem on the LeetCode. Given a string s, return true if the s can be palindrome after deleting at most one character from it. So it's simple valid palindrome problem. It's like we're checking if a string is a palindrome or not. But let's say if it was not palindrome, then you have a choice that delete at most one character. Delete if, let's say, if there was one character that was creating the problem, delete it and then check again. Simple, as simple as that. So we're given some examples here. Let's try to understand if they are palindrome or not. You know how to do a palindrome check. We have written solutions like that earlier. So now it's just all about like how to incorporate that deleting at most one character part and still checking if it is a palindrome. So this is example 1. X1, is it a palindrome? It's already a palindrome. So A, B, A, it's a palindrome, right? It is a palindrome. How about A, B, C, A? So here's the thing. This is where we use this delete at most one character part. So A, these two are equal, but these two are not, right? So we have a choice. We can delete at most one character. So we can delete B or C, any of these, and we can still have a palindrome. So A, C, A, this is a palindrome, this is a palindrome, and this is also a palindrome. So any of them becomes a palindrome, right? So how about this one? Example 2, example 3. Example 3, this is basically not a valid palindrome, and even if you delete any of these characters, it still is not a palindrome. So none of them become a palindrome even if we choose to delete one character from the given string. So how are we going to do it? So it's a two-pointer approach thing, so we're going to use constant memory and play around with the pointers. How we do it is the biggest question. So let's get rid of this crap from here and see A, B, C, A. This is the problem where we deleted at most one character. So let's see how we're going to solve it using two pointers. So what we need to do is we're going to have two pointers, start and end, and we're going to do the palindrome check, moving the pointers towards each other and check if they are matching or not. But then since we have this freedom to choice to delete one character and still check if it is a palindrome, the remaining string is a palindrome, so that will be utilized. We will need a helper palindrome function, and then once we are using these two pointers to basically check these characters, then we might come across two characters which are not matching. So what we can do is, so let's say in this case what's going to happen is here, let's say when we are moving these pointers, so I'm gonna just remove this. So these two were equal, but once pointers come over here, these two are not equal. Then what we can do is we increment either of these and check if the remaining string is equal. So I think to make this example better, we can have basically C over here, right? So if we had C over here, then it's B that we can delete. But how do we check it's B that you can delete? So what we will do is, we have already checked the string that was to the left and the string already that to the right, and they are palindromes. That's why we reached over here. But now this string is not equal to this one. So what we will do is on the remaining string is we will delete B. So remaining will be CC, and still pointing start here. Sorry, you can't see it. So remaining will be CC, and if you choose to delete C, then it would become BC, right? So is this palindrome or is this palindrome? You gotta check. Then we will basically have an OR condition in between and call again these helper palindrome on the remaining string. All right, pretty easy. Just move start pointer in one of the case and decrement end pointer in keeping the start pointer same in another case, and check if that string is still a palindrome. Implementation is going to be super easy, and I think it's going to be super straightforward, and you will just thank yourself that how smart you are. Okay, so let's have a helper function. Let's call it is palindrome. Okay, is palindrome. It's gonna take left pointer. I'm gonna call it start and then end. And what it really is gonna do is using these start pointers and end pointers. It's basically gonna have a while loop. While start is less than end, then keep checking if if s at start is not equal to s at end, then you return false. Otherwise you increment start and decrement end. Okay, that's it. Otherwise you return true. If you check the entire string using start and end pointers coming together, and then oh my god, from the back, from the front, it seems same, all the characters same, so it's a palindrome, so return true. Now what we do is we have this start pointer for the s string. So this was a helper function. Okay, this is helping us check if some string, not some string, s string will be checking for, but forget about it for now. So it's going to be 0, and then for end it's going to be len s minus 1. Always remember that. Now what we do is we're going to have the same this function. So while start is less than end, okay, and we come across if my start s start is not equal to s end. So in usual scenario we return false, but in this scenario, because we have a choice to delete any of those characters where they're mismatching, so we could move one pointer, ignore it, you just ignore it, and then check the rest of the string for this part, or ignore this part and check the remaining string forward. Okay, so in this case what we will do is we will return is palindrome function on start plus 1. So you're basically ignoring this start, and or this one. So either of them has to be true, and in this case you're ignoring the remaining the last pointer basically. Otherwise you basically, what do? You keep incrementing start and keep decrementing end. All right, and then just return true. Okay, that's it. Let's run it on examples. And we have just little problem here, and that is this. All right, these are fairly common, these syntax error, they're easy to make mistakes with. So let's submit it, runs on the example, and write down the time complexity. Time complexity is big of n, since we are basically using pointers to iterate the entire string, and whenever you come across mismatching, check with the main function. This is our main helper function. Otherwise, this is okay too. So it might happen that you never ever come across two strings that are mismatching. Then also you just come out of here. Even if you do, then you are only checking, you're only running this is palindrome helper function on the remaining string on either part. Okay, so and space complexity, that is why would be space complexity, that's why would be big of 1, because we're not using any extra space. So let's go to AlgoYogi and mark this problem also solved, and see you guys in the next problem. Until then, bye bye.